Dear students, in our previous class, we have discussed about searching and sorting, then insertion and deletion. Under searching, we have discussed two things. One is linear search. The next one is binary search. And under sorting, we have discussed about the insertion sort. So today we are going to discuss about the two-dimensional array. So far, what we have discussed is regarding one-dimensional array. But today we are going to discuss about the two-dimensional array. Before going to two-dimensional array, I will make you clear a thing about the insertion sort. So let us move one more time to insertion sort so that we can understand the sorting method clearly. What actually the sorting means? Sorting. Okay. Sorting means the arrangement of elements of the array in some order. This means array elements can be arranged either in ascending order or in descending order. Some order means either in ascending or in descending, order. There are many types of sorting, as we have discussed in our previous class. That is selection sort, bubble sort, quick sort, heap sort, insertion sort, and so on. And many types of sorting techniques are there. So in your syllabus, we will discuss only the insertion sort. Okay, come now we shall discuss the insertion sort. What actually the insertion sort means and how the insertion sort technique will work while sorting the elements. Insertion sort. Okay. In this type of sorting technique, what is there? First, we will think the first element as in correct position. Okay. The first element of the array assumed to be in correct position. Then after that, what we will do? We will think the next element as the key element. The next element is considered as the key element, and it is compared with the elements before the key element. Key element, and the element is inserted in correct position. Element is inserted in correct position. Element is inserted in correct position. As I have taken the example from textbook. So in this class also I will take the same example from the textbook. That is 70, 30, 40, 10 and 8. Okay, look here. Now you have to see this insertion sort technique. What we have to do, the first element of an array assumed to be in correct position. Think this 70 as incorrect position. Okay, then what we need to do, the next element is considered as the key element. Think this as the key element. Okay, now what we have to do, and it is compared with the elements before the key element. The key element is compared with the elements before the key element. So now compare 30 with 70. Okay, though 70 is greater than 30, so bring 30 to the first position and move this 70 to the next position. Then this will become like this. Okay, now 30 is smaller than 70, so this is in sorted order. Now take 40 as the key element. 40 as key element, then compare with 70. Then what will happen? 70 is greater than 40. So this will become like this. 40 will come forward. 30, 40, 70, 10 and 8. Okay. If we take this as key element and if we compare with 30, okay, then what will happen? 30 is smaller than 40, so no changes will take place. Okay, 40 is bigger than 30, so no changes will take place. If we compare 70 with 40, then also for 70 is greater than 40, no changes will take place. Okay, now 30, 40, 70, 10 and 80. Take 10 as the key element. 10 as the key element. Okay, for your reference, I will write one more step. Okay, 30, 40, 70, 10, 80. Look here, 40 is greater than 30. This is bigger element than 30. So no changes will be there. It will stay as it is. Now take 70 as key element. It is compared with 40. So here also 70 is greater than 40. Bigger element than 40. So no changes will happen here. Now write down as it is. Now compare. Take 10 as the key element. Take 10 as the key element. Compare with 70. So 70 is greater than 10. 10 is lesser than 70. So one step bring forward. 30, 40, 10, 70, then 80. Okay. Again take 10 as the key element. Okay. Compare with 40. So here 40 is greater than 10 and 10 is lesser than 40. So interchange the elements. 30, 10, 40, 70, then 80. Okay. Again compare. Take 10 as the key element and compare with 30 because this is smaller one. Okay. Compare with 30. Again 10 is smaller than 30. 30 is bigger than 10. So this will become 10, 30, 40, 70, 80. Look here. Now, we have checked every element as a key element. See, 30 checked as key element. Finished. Then 40 we have checked as key element. This is also finished. Then 70 we have checked as key element. Its work is also over. Then 10 also we have searched as key element. Its work is also over. Now only we have left with 80. So think this as key element and compare with 70. Or if you try to compare with every element, okay, then at the time also 80 is greater than all the elements. Okay, if you compare with 70 or 40 or 30 or 10, okay, at the time 80 is greater than every element, so no changes will take place. The elements will remain as is. So finally, we have got the sorted list of elements. Like this, the insertion sort will work. First element take as it is in correct position. Then take next element as key element. And then compare with every element before the key element. Then finally, we will going to get this type of answer. Okay, like this insertion sort will going to work. So hope you have understood. Next, come to two-dimensional array. Two-dimensional array. Two-dimensional array. So dear students, we have discussed one-dimensional array as a array of a single row or a single column. But how can we define the two-dimensional array? Okay, a two-dimensional array can be defined as it is the array of elements. Two-dimensional array is the array of elements. A two-dimensional array is the array of elements. Is the array of elements. Okay, then each element is identified by a pair of indices. Called subscript. Then here also the elements are stored in contiguous memory locations. Contiguous memory locations. Okay. Now listen here. Now we will try the two-dimensional array. Okay, I'll write an array representation. Okay. 3. Okay. I'll take textbook example. 2 minus 2, 3, 1, 0 minus 3, then 2, 2, 3. Okay, here we'll take it as 0, 1, then 2. Here a of 0, a of 1, then a of, look here. What the one-dimensional array will define, it can be defined as an array of a single row or a single column. But a two-dimensional array, it is an array of elements. Each element is identified by a pair of indices. What is indices? See, this is, you have already know that this is subscript. Okay. Then here also a of 1, 2, 3, they are also subscripts. Okay, subscripts and subscripts. They are also subscripts and these are also subscripts. What in one dimensional array we will do? We will just take the element subscript as just a of 0, okay, or a of 1 or a of 2. Like that we will take in one dimensional array. One dimensional array can be represented by just one indices, which is called as a single subscript. But in two dimensional array, it is represented by a pair of indices. Okay, it is having two indices. I will show you later. Two indices which are called as subscripts. Here consider a of 0, 1, 2 and 3. Okay, we will take like this. See, if you want to represent 2 in one dimensional array, it means an element 2 will be represented as, first take the column number a of 0, okay, then take the row element, row subscript, then take the column subscript a of 0, 0. This means the element 2. A of 0, 0 is the element 2. Then take a of 0, this one, right, for minus 2, a of 0 of 1, a of 0 of 1. Okay, like this we will write in two dimensional array. Then for element 3, a of 0, okay, then 2, a of 0, then 2. Then come to the next row element, a of 1, 0, okay, a of 1, 0, okay, then a of 1, 1, a of 1, 1. Then for this one, for this element now, okay, for minus 3, a of 1, 2, a of 1, 2. Okay, then after that, for this element, for 2, a of 2, 0, a of 2, 0, okay, then a for again 2, a of 2, 1, a of 2, then 1. Now for last final element 3, that is a of 2, 2, okay. A of 2, then it is 2. So here what it is explaining, represented by each element is identified by a pair of indices. See, one element, element 2, is represented by two indices. Okay, like this element 1 is represented by a of 1, 0, a of 1, 0. Then 2, the element, each element is a single element represented by a of 2, 1, a of 2, 1. Like this, a two-dimensional array can be identified and they are called as subscript. These indices, okay, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, all these are called as indices, and these indices are called as the subscripts. Okay, hope you have understood this. Now, in every array should have m into n columns, m rows and n columns. And this array, which is having two indices, it can be represented as a of I, j. A of I, j. I means the row elements. Okay, 0, 1, 2. J means the column subscripts. Okay, A of I, j means A of ith row. Okay, and jth column. Okay, a of I means a of 0, a of 1, a of 2. Then j means 0, 1, 2. Like this, we will represent a two-dimensional array. After that, okay, here The number of rows and columns of an array is called as an order. Okay, the row m into n. Okay, the rows into columns. This can be represented as a of I j. Okay, here the number of rows and columns. Every matrix is represented by rows into columns. That is called as order of a matrix or order of an array. Okay, and this order is represented by m into n. Okay, rows, number of rows into number of columns is called as an order. Okay, and this order is represented as m into n in an array. Okay, now take the example for this. Okay, what is the order of this array here? Now m into n is the order. M into n. M is equal to rows. Okay, then n is equal to columns. Okay, so m into n, which is equal to, okay, don't get confused here. I'm doing this. Okay, which is equal to m means number of rows. 1, 2, 3. 3 rows are there. 3 into then n means columns. 1, 2, 3. Which is equal to 3, that is equal to 9. The order of a two-dimensional array is 9. Order of this array is 9. Number of rows and into number of columns, which can be called as an order of array. Okay, hope you have understood regarding two-dimensional array. Things are there in two-dimensional array which we need to discuss. Now come to the representation of two-dimensional array. Representation of two-dimensional array. Two-dimensional array. Okay, before representing two-dimensional array, we have to take the order of an array m into n. Okay, where m is equal to number of rows. Okay, and then n is equal to number of columns. Now, by keeping these things in mind, okay, we will see the definition of representation of two-dimensional array. How can we represent the two-dimensional array? Suppose A, okay, is an array, okay, of order m into n. Take an array by name A, which is having order m into n. To represent, okay, suppose A is an array of order m into n. To store m into n, okay, I will write it in computer language, m into n. To store m into n elements, we need m into n memory locations. M into n memory locations. M into n memory locations. And finally, the elements should be in the elements should be in contiguous memory locations. Contiguous memory locations. Now look. Suppose A is an array of matrix. Think A, it is an array of matrix or array of order m into n, which is equal to m into m. Anything it may be 3 into 3 or 3 into 4. Okay, anything it may be. I will take the previous example only 3 into 3. To store m into n elements, to store 3 into 3 elements. Okay, think m into n as 3 into 3. To store m into n elements, okay, we need m into n memory locations. We need to 3 memory locations. Okay, this is 3 and into 3 memory locations. Right? The element should be in contiguous memory. Contiguous means one after the other. Should be in contiguous memory locations. Like this, we have to represent the two-dimensional array. But representing two-dimensional array includes two types. The first one is row major order. Row major order. And the next one is column major order. Column major order. The first one is row major order and the next one is column major order. So representation of dimensional array, two-dimensional array includes all these things. There are two types. One is row major order. The next one is column major order. Now come, we shall see what is meant by row major order. Okay. We shall see what actually the row major order is. How by row major order we can represent two-dimensional array. That is row major order. Row major order. Okay. What this row major order states? In row major order, okay, we'll take the same example. Let A be an array okay, of order m into n. Okay, of order m into n. Then here, what will happen? How the row major order works? Okay, here let A be an array of order m into n. In row major order, the elements of first row are stored at first. Okay, and then the elements of second row, okay, second row are stored, and likewise the same thing, then the third row, then fourth row, then fifth row, like that, and finally it can be written as and so on. Okay, I will give you the example here. Take the same 3 cross 3 order, that is 3 into 3, two-dimensional array of order 3 into 3. How? 0, I think. 2 minus 2, okay, 3. Wait a minute, just a minute, I will show you. Okay, we'll take this order. In row major order, how can we represent the array elements? This is 0, okay, 1, then 2, then A of 0, A of 1, then A of 2. See, what it is saying in row major order, let A be a matrix of order m into n. Think this as A be an array of order m into n. Think array by name A. Okay, this is an array by name A, which is having order m into n. M into n means that is 3 into 3, or it can be called as 3 cross 3, 3 into 3. Here in row major order, the elements of first row are stored at first. Okay, elements of first row. Okay, 2, 3. Look. At first, elements of first row are stored at first. And next, the elements of the second row are stored. Then the elements of second row, 1, 0, minus 3. And so on. And next, it will be continued to the next row. In row major order, in any array, according to row major order, the elements will get stored row by row. First in the first row, then in the second row, after third, fourth, or fifth, any number of rows it may be. But in row major order, elements will going to be stored in row order. That means first row, second row, third row, like that continuously it will going to be stored. Now we are having a formula to find the location of the element in two-dimensional array. Just like in one-dimensional array, here a formula for row order is little bit different. That is, take formula as location of A of, okay, I into j. A of I into j. We have taken as A of 0, but here pair of indices are there, 2 subscripts. So we are taking like this, which is equal to base A, that little bit small, okay, so that I can able to write in just one line. Location of, okay, A of I, okay, then j. A of ij, that is equal to base A plus, okay, plus W into, okay, we'll write this one below here, okay, which is equal to base A of, okay, plus W into n of I minus LB plus, okay, j minus LB. This is the formula to find the location of element according to row major order. Remember this, location of A of j, which is equal to base A plus W into n of I minus LB plus j minus LB. Hope you have aware of all these things. If no, I will explain you later while deriving problems based on these formulas. Okay, this is for row major order. The next thing is come to column major order. Here, look, column major order. Here, the same thing. Let A be an array of order m into n in column major order. In column major order, the elements of first column, are stored at first, and then the elements of second column, are stored, and so on. I will show you with the same array. See, let A be an array of elements m into n or order m into n. Here what will happen? In column major order, the elements of first column are stored at first. The elements of first column, that is 2, 1, 2. The elements of first column are stored at first. And then the elements of second column are stored, and then so on. Then elements of second column 0, then okay, here inserting elements column wise, storing elements column wise. Then finally, the last column again, not the same elements. We can insert any element. Here I am taking negative values also, so that you can understand this is not just the, we will not just give the positive values. In elements, we can give negative values also, but in subscripts, okay, we have to give only the positive values. Here, no negative values, but in elements, we can give the negative values. The elements in column major order, the elements of first column are stored at first, and then the elements of second column are stored at next, and finally, and so on. Any number of columns it may be. Then third column, fourth column, fifth column. Likewise, we can store the elements column by column with the help of column major order. So this column major order is also having a formula same as the row major order. This is a row major order formula. Okay, this is row major order formula. Column major order formula is also there. I will write that formula here. Location of, okay, A of ij, A of ij, okay, is equal to, which is equal to base A plus, okay, base A plus I minus LB into I minus LB plus, okay, plus m into plus m into j minus LB. Look here, the formula is like this for column major order. Location of A of ij, this is j, okay, this is j, which is equal to base A plus I minus LB. See here in column major order, n into I minus LB, okay, but in row major order, I minus LB plus m into j minus LB, plus m into j minus LB. In row major order, we have taken n here, okay, but nothing here. But in column major order, we have taken m beside j. That is the difference. Okay, hope you have understood regarding row major order and column major order. Now, take an example, and by applying these two formulas, we will try to solve a problem using the formulas of row major order and column major order. Okay, the problem is like this. I take it from your textbook. Okay, one more thing I want to show. Here in column major order, before going to solve a problem, I'll show you one more thing. We'll take the same example. Okay, come to row major order first. Okay, row major order. Row major order. What this row major order says, the elements of first row are inserted first. Take a array representation. Okay, how many are there? 9 are there. Okay, 1, 2, 3, 4, 5, 6, 7, 8, then 9. Take their address as 2001, 2002, okay, then 2003, likewise, then 2004, then 2005, then 2006, then 2007, then 2008, then 2009. Okay. According to row major order, how the elements are going to be stored. Okay. The first row elements are going to be stored at first. The first row element. Okay. First insert 2. Then minus 2. Okay. Then first row elements are inserted. How the subscripts or indices can be taken as for 2 a of 0 0, a of 0, okay, then 0. Okay, for minus 2, this is a of 0 1, a of 0, then 1. Okay, then for 3, a of 0 2, a of 0, then okay, first row elements are inserted. Next, second row elements will going to be stored 1 0 minus 3, 1 0 minus 3. How this can be written as 1 a of 1, then 0, a of 1, then 0. Okay, then a of for 0, a of 1 1. Okay, a of 1 1. Okay, this 0 is stored here. Then this minus 3 is stored here. Then for minus 3, a of 1, okay, a of 1, then 2, a of 1, 2. Okay, then finally the third row, 2, 2, 3, 2, 2, row elements are inserted. Then for 2, for this 2, okay, this 2 is stored here, a of 2, 0, a of 2, 0. Okay, then for this 2, this is stored here. Okay, a of 2 1, a of 2, then 1. Okay, then for 3, it is stored here, a of 2, then 2, a of 2, then finally this is 2. See, like this we can store in row major order. Okay, then come to column major order. How the elements will be stored in column major order. In column major order, the first column elements are stored at first, and then the next column elements, second column elements are stored at next, and then finally the third column elements will going to be stored. Okay, in column major order. Okay, column for column major order, first column elements. Okay, take 2 1 2, 2 1. Okay, this can be written as for 2. Okay, it is stored here, a of 0 0, a of 0, then 0. Okay, then 1 is stored here, for this a of 1 0, a of 1, then 0. Okay, then 2 is stored here, for this 2, a of 2 0, a of 2, then 0. Then take the second column elements, minus 2 0 2, minus 2 0, then okay, for this minus 2, a it is stored here. Okay, this minus 2 is stored here. So for this, take the values, take the subscript, a of 0, okay, then 1, a of 0, then 1. Okay, this 0 is stored here. So for this 0, take a of 1, then 1, a of 1, 1. Okay, then 2. Okay, this 2 is stored here. For this 2, take a of 2, then 1, a of 2, 1. Okay, then finally we have left with third row, 3 minus 3 3, 3 minus 3. Okay, you can put any elements. No needed that only you have to take this type of elements only, not like that. You put any element, take negative values or the positive values, but every cell should contain only one element. Okay, then 3, 3, it is having A of 0, then 2. For this 3, A of 0, 2. A of 0, then 2. Okay. Then minus 3 is stored here. And for this, A of 1, then 2. A of 1, then 2. Okay. Then finally, this 3 is stored here. Then for this 3, first take row. Okay. A of 2, then A of 2, then like this. Elements are stored in column major order. So by these, okay, entries, you have aware row major order and column major order. Okay, come. Now we shall take a problem and we will try to solve that problem using row major order and column major order. I'll write a question also so that you can understand how this will going to work. Okay, consider array A of order 25 into 4. Consider array A of order 25 cross 4. Okay, this means m into 25 into 4. The base value 2000 with the base value 2000 and one word per memory location and one word per memory location. One word per memory location. Find the address of A of 12 of 3. Okay, find the address of A of 12 into 3. Okay, two indices, that is two subscripts. A of 12 into 3 in row major order and column major order. In row major order and column major order. And column major order. Okay, here given. What is given here? Okay, given, we will take given as, okay, A of I j, okay, which is equal to A of 12 into 3. I think 3 or 13. Okay, 12 into 3. Okay, A of I j is equal to 12 into 3. Then base A, okay, base A, which is equal to 2000. Okay, A of I j is 12 into 3. Base A is 2000. Okay, then order, yeah, m into n. Okay, m into n, which is equal to 25 into 4. Okay, therefore m is equal to 25. Okay, n is equal to 4. Okay, m into n, 25 into 4. So m is 25 and n is 4. Then what is here? Memory location. One word per memory location. One word means w is equal to 1. Okay, w is equal to 1. Then here a of ij is equal to 12 into 3. Therefore, I is equal to 12. Okay, I is equal to 12. Then j is equal to 3. J is equal to 3. Okay, now based on these values, we will try to find the location of an element. Okay, consider, Okay, find the address of this element here of 12 into 3. Okay, in which address this element has present, we need to find out. First, take by row major order. Take the row major order formula. That is, okay, I'll take formula here. Okay, okay. Location of, okay, A of to base A, okay, plus W into plus W into, okay, N into I minus LB plus, okay, I minus LB plus J minus LB finally close. More thing. Okay, like this. Location of A of IJ, okay, which is equal to A of 12 into 3, right? A of ij is A of 12 into 3 is equal. Base A is 2000. 2000, okay, plus W is 1, okay, into take N, okay, N is 4 into I, value of I is 12, okay, minus LB, lower bound. What is the lower bound here? Lower bound is always 0, okay. Lower bound, I will write lower bound here. It is always 0, okay, 0, okay. Then plus J, what is the value of J? 3, okay, 3 minus LB is always 0, okay, which is equal to, okay, this is equal to 2000 plus 1 into, okay, 12 minus 0 is 12, which is equal to 4 into 12 plus 3, okay, plus is here, then 3 minus 0 is 3. 4 into 12 plus 3, okay, this is equal to, okay, 2000 plus, okay, 1 into 12 4s are 48, okay, plus 3, okay, this is equal to 2000 plus 1 into 48 plus 3 is 51, okay, finally which is equal to 2000 plus, okay, 51, all right, yes. 51 into 1 is 1 into 51 is 51. Finally, which is equal to 2051. The location is present at 2051. Finally, we have got the answer as 2051 according to row major order. Okay. Then come to column major order. We will take an example for now. We will use the formula for column major order. In column major order, just n will be removed here. Okay, and write I minus LB, okay, plus m into j minus LB, okay, plus m into j minus LB, j minus LB, okay. A of ij is equal to A of 12 into 3, okay, which is equal to base A is 2000, okay, 2000 plus word W is 1 here, 1, okay, into I is 12, 12 minus LB is always 0, okay, plus M is 25, okay, 25 into, okay, J minus J is 3 minus here LB is 0, okay, which is equal to 2000 plus 1 into, okay, 12. 12 minus 0 is 12 plus 25 into 3 minus 0 is, okay, this is equal to 2000 plus 1 into 12 plus 25 into 3, okay, 3 5s are 15, 75, okay, 25 into 3 is 75, okay, 5 3s are 15, carry 1, 3 to the 6 plus 1, 7, okay, which is equal to 2000 plus 1 into 12 plus 75. 12 plus 75. That is 7, 87. Okay, 87. If you add this one, this will become 87, which is equal to 2000 plus 1 into 87 is 87, which is equal to 2000 plus 87 will become 2087. And finally, we have got the answer as 2087 in column major order. Okay, first we have done got 2051 in row major order. Now we have done with column major order and we have got it as 2087. So dear student, this is regarding two dimensional array. Okay, the most important thing here is row major order and column major order. This is very much important for your examination. It compulsory it will be asked. Okay, either row major order or column major order, or the problem will be asked, or else both the things will be asked for your exam. Okay, regarding row major order and column major order. Okay, dear students, regarding this, if you have any doubts, you can ask me personally. Thank you.